concept and what is the meaning of molar mass, okay, in gram. See, actually the mole, it is referring to, it is a fundamental unit of, it is one of the fundamental unit, okay. See, same way, it is a fundamental unit of quantity. Same way, we can say, 1 dozen, it stands for 12, right? Okay, or 1 pair, okay, it stands for 2. Same way, 1 score, it is a 24, okay. And same way, if you are taking, like 1 mole is, it is 6.022 into 10 raised to 23 number of atoms or molecules, whatever it could be, okay. Suppose if I am taking 12 pen of this kind, okay, so it is going to be 1 dozen, or else 2 pen, it is going to be 1 pair. If you are taking 6.022 into 10 raised to 23 number of entities, it could be molecule or it could be atoms, okay, and that is going to be 1 mole. Actually, the same digits, 12, 2 or 24, these kind of digits, we cannot apply in the case of atomic scale quantities, say atoms, or atomic scale entities, say atoms or molecules, because those if you take a 12 atoms, how much its mass, it is going to be, it cannot be even measured using the ordinary equipments, right? Okay, if you take a 24 number of carbon atoms or like oxygen atom, that is also not going to be easily measured. It is not possible to measure using the ordinary laboratory scale apparatus and all. See, when we go into the atomic scale entities, we need to have some specific units, specific number in order to apply this, in order to make the concept, or in order to make the things easy and applicable in our day-to-day life or in the laboratory conditions at least, okay. See, let's see how this particular number has come, okay. This number, anyway, it is known as Avogadro's number. A stands for Avogadro, N stands for number, okay. See, by definition, 1 mole is, if you take a 12 gram of carbon you already know, it is one of the isotope of carbon. If you take a 12 gram of carbon, how many number of carbon atoms are there? That is going to be 1 mole, okay. See, let's see how we can do it. See, the mass of 1 carbon 12 is, 1 carbon 12 atom is, it is 1.99 into 10 raised to minus 23, okay. So this is the mass of 1 carbon 12 atom, okay. So in 12 gram of carbon 12 you are taking, how many number of carbon atoms will be there? So obviously we can calculate. You see, number of carbon 12 atoms in 12 gram is equal to 12 divided by, this is the 12 gram, this is nothing but atomic mass also, okay. 12 divided by 1.99 into 10 raised to minus 23. So you will get around 6.022 into 10 raised to 23 you will get, okay. That means, if you take a 12 gram of carbon 12, it will contain 6.022 into 10 raised to 23 number of carbon 12 atoms, okay. So this is how this digit has come. This digit is, as I told you already, it is known as a Avogadro's number. See, we can see how big number it will be. See, if I am just writing it in the proper way, okay, this I can also write, okay, 6022 000 000 as of now it is 9 zeros, right? Again 0 0 0 12 13 14 15 16 17 18 19 20, okay. So see, how much bigger digit it will be. So see, if you take this, if you take 12 gram of carbon atoms, okay, it will contain this many number of carbon atoms, okay. So like the same way, the 1 dozen is 12 or 1 pair is 2. Okay, so 1 mole, it is going to be 6.022 into 10 raised to 23. See, as we know, it is not necessary, we cannot apply, or like it is not necessary that we have to apply these bigger digits in the case of ordinary macroscopic objects, right? Okay, if you take this 1 mole of a pen, 1 mole of pen, it will be like 10 raised to this many number of pen I have to take. Okay, so these kind of digits, this Avogadro's number, it is applicable in the case of I mean the atomic scale entities, say atoms or molecules or like a compound center. Okay, and let's see how much is the 1 mole of other substances. If you take 1 mole of CH4, it is going to be 16 gram. Okay, or else if you take 1 mole of H2O, that is going to be 18 gram. See, can you understand from where this 18 has come? Okay, what is the molecular weight of water? It is 2 plus 16, right? So it is going to be 18. So the molecular weight of water is nothing but 18, right? Okay, so now it is or else you can, here also you can see the molecular weight of CH4, it is 12 is the atomic mass of gram atomic mass of carbon, and 4 into 1, that is going to be 16, right? So that is the gram molecular weight of methane. Okay, so same way, if you take 23 gram of sodium, that is also going to be 1 mole. From where this 23 has come? 23 is the atomic mass of sodium. Okay, like if you take a 35.5 gram of chlorine, that is going to be 1 mole of chlorine atom. Okay, now it is possible to, now it is easy to define what is a gram molecular mass. Okay, gram molecular mass is it is nothing but the atomic mass or molecular mass. Okay, we are gram molecular mass, it is nothing but the molecular mass, we are expressing it in the gram. Okay, and 1 gram molecular mass, it will contain Avogadro's number of particles. For instance, the 18 gram is the gram molecular mass of water. This will definitely contain Avogadro's number of particles. 6.022 into 10 raised to 23 number of water molecules will be there in 18 gram. Okay, same way, here also 6.022 into 10 raised to 23 number of methane molecules will be there in 16 gram of methane. Okay, so hope you are clear what is gram molecular mass and the mole concept. Thank you.